Okay, so for page 2, number 3 says find the common ratio of the given sequence. So I'm going to look here. 7 times 3 is 21. 21 times 3 is 63, and 63 times 3 is 189. So the ratio is times 3. Okay, for B, 6 times 8 is 48. 48 times 8 is 384, and 384 times 8 is 3072. So my common ratio is times 8. Okay, what is the decay factor? Alright, when it says factor, then I'm just looking for this value. Okay, I'm not looking for the percent or the rate. I just want the factor. So the decay factor is 1/4. What is the growth factor? Again, I just want this number here. I'm not looking for the rate or the percent, so it's just 3. Okay, what is the exponential function for the information listed? Alright, 2 things here. First, my function is always y equals a times b to the x power. Okay, so my a is my starting point. That's where x equals 0. So that's just going to be 1, which I don't have to write, but for this I'm going to write it. And then my pattern is my b. So here I'm going to look at these numbers first. 1 times 3 is 3. 3 times 3 is 9. And if I did that over here, it would work too. So my pattern is 3 to the x power. Okay, simplified, I can also write it like this. Okay. Alright, my next one. Alright, so again, y equals a times b to the x. My starting point again is 1. So my a is 1. And my b is going to be my pattern. Alright, now this looks like divided by 4. But remember, I never write divided by 4. I want to write times 1/4. 4 times 1/4 is 1. 1 times 1/4 is 1/4. Okay, so I'm going to write that like this. Or like that will work too. Okay, so let's look at 6. Okay, so you plant a tree that's 3 feet tall. The variety of tree doubles in height every 1.5 years, where x is the number of 1.5-year periods. Alright, so state the exponential function representing this information. Okay, so my starting point is 3. I know that it doubles, so times 2 to the x power. Okay, now based on this information, what is the height of the tree in 4.5 years? Alright, so I'm going to use the same function here. Okay, and I need to figure out how many 4.5-year periods, or how many 1.5-year periods are there in 4.5 years. Okay, so I'm going to take 1.5, okay, plus 1.5, that's 2 periods, is 3, and then one more is going to be 4.5. So there's 3 periods here. Okay, so that's my number that's going to go for my x. Okay, so then I can plug this in my calculator. I know that 2 cubed is 8, so y equals 24. Okay, so the tree will be 24 feet tall. Okay, let's look at 7. Okay, so 7 says a population of 4 rabbits triples every 8 months, where x is the number of 8-month periods. Okay, state the exponential function representing information. So y equals, the starting point is 4. I know that it triples over my number of periods. Okay, based on the rabbit population, or based on the information, what is the rabbit population in 4 years? Okay, I need to know that 4 years is 48 months. Okay, and then I'm going to divide that by 8. So that's 6 periods. Okay, so y equals 4 times 3 to the 6th power, which, let's see here, I need to get my calculator out. Okay, and I'm going to go to, let's see, 3, 6 power times 4. Okay, y is going to equal 2916. Okay, and we're just going to enter that in our calculator. All right.